You know, we hear so much about AI models, but what about the actual systems that are built around them? Today, we're going to peel back the layers on a really powerful AI coding agent, Claude Code, to see how it's actually built and what makes it tick.
So, just imagine for a second, what if an AI could be your true coding partner? I'm not just talking about something that suggests the next line of code. I mean a tool that can plan, write, run, and even debug your code all on its own to reach a goal. Well, that's the big promise of what we call agentic AI.
So, what does that term AI agent system really mean? Well, think of it this way. It's an AI that goes way beyond simple suggestions like your everyday autocomplete. It can actually autonomously plan and carry out a whole series of steps to get a job done. The key here is independent action, not just a simple prediction.
To really get a feel for this, we're going to look under the hood of a real-world example. So let's meet our AI coder for today, Claude Code. And throughout this whole explainer, we're going to follow Claude Code on a very common, very real-world task that any developer will recognize. Fix the failing test in auth.test.ts. This one simple request is going to show us the incredible complexity working just behind the curtain. Now, here's a stat that might just blow your mind. What part of this entire system is actually the AI model making the decisions? Just 1.6%, that's it. The other 98.4%? That's all the operational plumbing, the safety systems, the guardrails. Basically, it's everything that makes the AI not just powerful, but also safe enough to actually use.
And that massive infrastructure, that 98-something%, it's not just a random collection of code. It's built on a really solid foundation of clear principles. So let's dig into the 5 guiding values that pretty much act as the system's conscience.
Okay, number 1, and this is the big one, human decision authority. The entire system is built around one unbreakable rule. The human is always in charge. The AI can suggest, it can act, but you, the user, always have the final say and the power to pull the plug at any time. Next up, a really deep commitment to safety, security, and privacy. And this goes beyond just doing what the user asks. The system actually has a duty to protect you, your code, and your data from harm, even if you're getting a little click-happy and not paying full attention.
The third value is all about reliable execution. You know, it's crucial that the agent does what you meant for it to do, not just what you literally typed. It has to stay on track during long, complex tasks, and, this is super important, it has to check its own work to make sure the job is actually done, and done right.
And this leads to something really cool, capability amplification. The goal here isn't just to make you a little faster at the job you already do, it's to give you the power to do completely new things. And the data actually shows this. One study found that 27% of the tasks people did with Claude Code were projects they wouldn't have even tried to do on their own.
And the final value holding this all together is contextual adaptability. The system is designed to learn and adapt to your specific project, your tools, and the way you work. This means the relationship between the human and the AI isn't just static, it's a partnership that's built to grow and get stronger over time. Okay, so we've got these core values, but how do you actually turn those ideas into code? Well, let's look inside the system's heartbeat, the agent's loop. It might actually surprise you how simple the core of this whole thing is. The engineers behind it put it this way. The core of the system is a simple while loop that calls the model, runs tools, and repeats. That's really it. All the magic is in the systems that are built around this incredibly simple loop. And this diagram just lays it out perfectly. It's this constant 3-step cycle. First, it gathers context. You know, what's the goal? What does the code base look like? Second, it takes an action. Maybe that's running a test or editing a file. And third, the super important part, it verifies the results. Did that actually work? And then it just repeats over and over until the job is done. Okay, I know what you're thinking. Letting an AI just run commands and edit your files, that sounds kind of risky, right? And that brings us to maybe the most critical part of the whole architecture, the digital guardrails that ensure safety is the default setting. So why do they need so many safety layers? Well, it comes down to this really fascinating insight into human behavior. Researchers found that we humans approve about 93% of permission pop-ups. We get what's called approval fatigue. We just get used to clicking yes without really thinking. And that means you just can't rely on a person to be the only safety check. The system has to have its own brakes. So to deal with that, they made a really fundamental design choice. Most systems use an allow-first approach. That's kind of like having an open door and only locking it for known threats.
Well, Claude Code does the exact opposite. It uses a deny-first posture. This is like having every single door locked by default, and an action is only allowed if there's a specific rule, a specific key, that explicitly allows it. Anything else gets sent straight to the human. It's just fundamentally safer.
And it doesn't even stop there. This is a strategy called defense in depth. An action doesn't just pass one little check. It has to get through 7 completely independent layers of safety. We're talking everything from filtering what tools the model can even see, all the way to running commands in a totally isolated sandbox. Any single one of these layers can stop a risky action in its tracks.
And this is where it all just clicks into place. We can now draw a straight line from those abstract values we talked about at the beginning to concrete, hard and fast engineering principles. That idea of human authority? That becomes the deny-first rule system. Safety and security? That becomes defense in depth. This is where the philosophy actually becomes the architecture. It's fantastic. So, what does this all mean for the future? As we build these incredibly capable AI partners, what is this new human-AI partnership really going to look like?
Well, it brings up this really tricky problem, and it's called the paradox of supervision. The idea is, as the AI gets better and better, we might start to rely on it too much. And by doing that, we risk weakening the very judgment and skills we need to supervise it effectively and catch it when it does make a mistake.
And that leaves us with a huge question to think about for the future. As AI becomes a better and better partner, how do we make sure that we remain good supervisors?